Forward button for me.
All right.
Awesome. Thank you.
Awesome.
And I want to welcome everyone one more time. And for everyone who is joining us, welcome to this presentation. I would like to know who was with us yesterday, where we were learning more about AI. And today I have another expert from our school. His name is Matthew, and he will be taking us deeper into the knowledge about machine learning. I'm excited to learn with you tonight. And we are recording this presentation. So if you want to share it with someone who wasn't able to make it, you're more than welcome. We would appreciate it. And everyone who is joining, I see Nina just joined us. Welcome to this presentation. So we are going to be learning about machine engineering industry and how to apply it, how to be developing yourself and your skill set as a machine learning engineer. And I just want to give you overview about our company. I don't know who was with us yesterday. So if you missed last night's presentation, I had a great expert with us too last night too. We can send you the recording. And I think we sent it to a lot of people who was with us. Thank you for everyone who is joining us. Let me know where you joining from. Just check, just write it in the chat so we would know who's with us tonight. I know last night we even had someone from Hawaii. If you are watching this presentation in recording, welcome. And I'm excited about learning with you. And congratulations on learning a new skill set. And I hope tonight you'll learn something new. Mary Jesse, welcome. Atlanta, Georgia, welcome. Thank you so much for being active. So we're going to spend the next hour together. And so if you didn't get a chance to make yourself a cup of tea or something, take care of it right now before we dive in. I think I see that we do have new people, someone who wasn't with us last night. So I'm just going to give a quick overview of our company, and then I'll introduce you Matthew, who will be our expert tonight, and he'll share the some golden nuggets with us about machine learning industry. So Matthew, if you could share with me next slide, I'll just give you an overview about who we are and how the company was founded. So originally, the company was founded in 2016 in California. So this is not our first rodeo. You know, we didn't just get started yesterday. Since 2016, we had over 3,500 graduates who successfully found a job in US. And originally, the project was started for people who don't even speak English, who just moved to US and they were looking for opportunities. And so we decided to just launch this project and help people to get their dream career in IT field. And because we had so much success since 2016, we decided to make this program available for English speakers. And so right now we have over 25,000 students worldwide. And before we started, just to have a meetups, you know, in the office. If you could share the next slide, I would like to share few pictures of our students. So first it was would rent you know, some office and just have meetings. And since then, you know, we had so much success. And after COVID, as you know, a lot of companies they transition online. And we did as well, but it allowed us to give this opportunity not just for those who are based in California, but for people from different states. And I'm always excited to see where people are joining us because I think that it's an amazing opportunity that we could all live in the different parts of the world or the states, you know, and we could just learn together and pursue this dream career in IT field. So I want to welcome everyone again, and I see more people are joining. So stay with us till the end. If you have questions, post them in the chat, and we would love to answer all of them. And on my next slide, I wanted to just share with you if you would like to learn more about our students. You can check our reviews on our YouTube channel. And we already launched programs in English language, not just in different languages like we did previously. And so
Oh,
you could already hear some reviews. And we have more students joining. And I'm excited about this course about machine learning engineering because so we are still have available spots for this course. So I'm excited about bringing different experts and just showing you what a great opportunity it is. And it might be a great fit for your future. So we give you this opportunity. Cliff, Ken, welcome. I saw that you just joined. Let us know where you're joining from. And if you could share next slide, Matthew, I would appreciate it. So those are just a few companies, you name it, our students work all over. And once you have the skill set in machine learning engineering or IT, you can pretty much find job in any of these companies, and we make it possible. Can we see the curriculum and what is the tuition cost? Yes, Nina, that's a great question, and we're gonna discuss it after. I would like to bring Matthew, who would be our expert, and he would share some knowledge, and then we'll go over the curriculum and the tuition cost. And for everyone who stays with us till the end, we did prepare a special offer, which you will have opportunity to join. But before I go to that, I want to just mention the statistics which blow my mind is that the global machine learning market size was valued in US for 8.843 billion in 2021. I checked the statistics for 2022, it was over $19 billion. So by 2030, the market is projected to reach over 209 billion. And it's incredible opportunity. So it's perfect timing to seize this opportunity, get the skill set, and monetize on it. Also, a few more facts on the next slide. I'd like to show you that's very impressive to me too. And I'm a numbers person. You know, I spent a few years to get my PhD, and so I love just seeing the statistics. I love seeing where industry is moving, and it's important, I think, to share that. So 76% of companies they prioritize AI and machine learning over other IT initiatives in 2023. 47% of digitally mature organizations have a defined AI and machine learning strategy in place. And 64% of businesses, they report using machine learning in some form, with the highest adoption rates in the tech, finance, and healthcare sectors. So it just gives you an overview and facts that it's a great industry to be in. And if you missed our presentation from last night, please watch the recording about how can you use AI technologies and how you can um, monetize on it and become successful. And so right now, I would like to introduce you our expert, Matthew, and he will be sharing with us some knowledge about math of basic neural networks. His presentation is incredible. He is extremely smart person. I got a chance to talk to him before this webinar and he showed me a few numbers and I was so impressed. So I can't wait to hear Matthew, what you're going to share with us tonight. And thank you so much for just being with us tonight and sharing your journey in machine learning industry. And I'm very excited to let you know that Matthew will be one of our instructors in this program. So get ready, take some notes, prepare your questions, and let's dive in and learn some more. Matthew, I'll let you go from here. And for everyone who stays with us till the end, I told you we got special offer and prepare your questions and let's learn together tonight how we can do not miss this opportunity, which is incredible on the market nowadays. All right, thank you. And Matthew, can't wait to hear and learn from you tonight.
Yeah, thank you so much. All right, so yeah, it's a little about myself. I studied applied math in college. I understand a lot of the course is mostly focused on proving more fundamental aspects of machine learning models, data science, and making me really understand how to really dig into the modern latest research and be at the cutting edge. I have worked as a machine learning engineer for the Air Force. I would mostly research computer vision models. For the last 2 years, I also worked at Ben Labs. I did a lot of data engineering and helped with the ML ops and just kind of everything that goes around the actual machine learning model, like hosting API, hosting the machine model itself, that kind of stuff. And yeah, so yeah, really excited to meet you all. All right, so I guess we'll just get into the lecture. All right, so the purpose of, or the goal for today's lesson is to kind of recreate this basic neural network. So, all right, so, and machine learning is kind of two branches of thought. One is kind of more classic machine learning, where you don't have the time parameters, but everything's more kind of sort of custom built, and the models are really strong and powerful, but more simple, I guess you could say. And the other school of thought is called deep learning, where inside deep learning, what you have is you have these networks that are sort of inspired by networks in the brain, where we have these different input layers, and then we have these neurons, and we stack these neurons on top of each other, and together, all of this orchestrates to do predictions. So here, I can actually just show you this really quick. All right, so when a machine learning starts, at first, all its predictions are generally pretty bad. Like what this is supposed to do is supposed to classify the orange dots in the orange zone and the blue inside the blue zone. Right now, it just thinks everything's blue because it's just kind of randomized. But if we train it and we let it look at the data, we try to fine tune the parameters or fine tune this model to fit this data, we can find that actually does learn, in a sense, how to predict these models. And then if we add in the test data, it's able to, we're able to add new data. So this is the data that the machine learning was trained off of, but it's able to do more than just predict the broad data we gave it. We're able to introduce this new data and it's able to do predictions beyond our base data set. And so that's why it's learning, because we give it this information, but from that information, it's able to learn all of that. Okay. All right. So, all right. So how does this work? What is this architecture and how can we build it? All right, so we'll just start from the left and we'll go to the right and we'll talk about each piece little by little, okay? All right, so to begin, we have what's called the input layer. So the input layer can be lots of different things. It can be an image, it can be a time series plot, it can be a kind of CSV file where, you have these different numbers, category variables, whatever. It can be text, lots of different possible inputs. And once we get the input, what we have to do is we have to transform that into what's called a vector, where each of these numbers, each of these little neurons are just numbers. They can be between infinity and positive infinity, or you can count it if you want to. And once we have this vector, and by the way, every single machine learning model has to find some way to transform this input into a basic vector. Once we're here, everything else becomes more or less standard. It doesn't really matter what problem we're working at. All right, so now that we have this basic input layer, what we have to do is we move it on into what's called the hidden layer. So the hidden layer, what it does, is we take these inputs and then we combine them together to form a new value. So in this particular case, each of these little lines represent a number we want to multiply our inputs by. So in this case, this line is multiplied by 2, then 1, then 2, then 1 again. So as you can see, it's 1 times 2, it's 2, plus 1, plus 2, plus 1 is equal to 6, right? And so that's how this node is generated, okay? And this is a more precise formula for that, right? All right. Another thing we can add on is what's called a bias term, where we add this little +1, and this again can be wherever we want. It's not really dependent on the input. It's just something we add to a specific node. And then, however, though, of course, we want to generalize this not just to this one specific model, but to every possible model. So instead of using actual numbers, we just use variables, right? And we do this for every single node of the hidden layer. And what we can do is, as we construct this, we can actually transform it into a matrix multiplication, where, again, we have the same input, x1, x2, x3, and we have this bias term, which is 1. We multiply it by this, and that generates the next layer. So again, x1 times that, x2, x3, x4, and then x1, multiply together, add it, and we get this first number. And do the second number, third number, and fourth row, and so on. And so one thing that took me a little while to really click is this really cool architecture is able to learn really anything. It's just matrix multiplication, and it's actually pretty simple matrix multiplication too. Just matrix multiply, and we are able to update the nodes. And as we do this, we kind of change the shape of the information. Okay. All right, so yeah, so again, just simple matrix multiplication. Okay. All right, and so so now we have to ask ourselves, okay, why do we do this? Like, why are we doing this multiplication? What does this actually do to the data? Well, the trick all has to do with with the dot product. So the dot product, it's a pretty simple mathematical concept. All it is you take two points of high dimensional space, you multiply them together, and you try to figure out how similar they are. So in this example, I have two vectors. In this case, it's two-dimensional, but really it can be as many dimensions as you want. I just do two-dimensional because it's easier to visualize. So say, for example, this is the input vector, right? It can be, it has two numbers and right here. And these numbers, they can be anywhere between 0 and 1, and we can move around the space however we want, right? Okay, and then we have this feature vector over here. If we go back to the slides, this would be one of the things that go to the neural network. And so what this is doing is it's actually calculating how similar these two vectors are, that they're basically the same. Like if my input happens to be almost the exact same as the feature vector, then the dot product will be really high. Specifically, it'll be 1 right here, right? But if I make it dissimilar, if I make it orthogonal, then the dot product becomes 0. And the reason 0 is because this vector is 0, 1. This one is, if I just develop it right, there we go, it's 1, 0, multiply together, 1 times 0 is 0, 1 times 0 is 0, 0 plus 0 is 0, right? And in fact, if I make it really dissimilar, it can actually get negative. So all of this does is encode similarity, okay? All right, so coming back to this. And so the reason why that's really important is what we can do is if we can somehow find a way to get these vectors to represent something meaningful to us, then we can figure out how similar our data is. So like maybe in this example, what we have here is we have this image that's really just a bunch of pixels, right? So what we can do is we can take those pixels and we turn that into a vector. And then what this header node can do is maybe this vector can be something that's really similar to this 3. So if it's really similar to the 3, then we multiply the vector times the input. If it's really similar, then this will have a really high value for 3. Maybe this one can represent a 2, a 1, a 0, whatever you want. And then when it comes time to the output, what it does is it just figures out, hey, so this value is really high, my output is 3, because this corresponds or correlates really high with 3. This could be 2, 1, 0, whatever we want. And so here, to make this a little more easier to understand, I have this example. So what we do is maybe this neural network, all I want to do is I want to programmatically figure out the XOR operation. XOR is just simple Boolean logic, where like if you have two inputs, x1, x2, if they're both 0, the output is supposed to be 0. If 1 is 1, then the output's 1. If 1 is 1, if the other one is 1, then but the other first one is 0, then it's 1. But if they're both 1, it's 0. It's a pretty standard mathematical operation. And so this network we have right here is able to figure that out. So, if we kind of walk through this, again, the input can be either a 0 or a 1, nothing more, nothing less. So let's pretend that this is 0 and this is 0. I'll just quickly do the math. It won't take a second. So 0, 0, I multiply 0 by -1, multiply 0 by -1. I get to here, 0 plus 0 is of course 0. And then I add 1.5. Okay, so then this is 1.5. And then I come down here and I do the same thing, 0, 0, 0, and then this becomes minus 0.5. And once I have these values, there's nothing I have to talk about, and that's called the activation layer. So one more step is after we calculate these values, we have to do what's called activation layer, where all we do is it's supposed to be a non-linear operation, where it's not just a straight line. There's a part where it goes up and the part where it goes down, or stays steady and something like that. There's lots of different options, but for the network I'm trying to show you, I'm actually doing this binary step function, where if it's negative, I want it to be 0, and if it's positive, I want it to be 1. Okay, so coming back to here, again, this is 1.5, so that means this turns out to be 1. This guy over here, that would be negative 0.1, so that'd be 0. And then add this together again, that'd be 1, 0, 0, sorry, it'd be, that's right, 1, and then 0. And then 1 minus 1.5, that's negative 0.5. I do have this again, and that becomes 0. And so I know it's a lot of words, but really this is, you can do, the input holds for this every single time. I won't take the time to go through this one by one, but if I try 1, 1, I'll get the same thing. I'll get 0 in the output again. If I try 1, 0, I'll get 1. If I try 0, 1, I'll get the output. And so the point is that, what this can predict can really be almost anything, actually. In fact, there's actually mathematical proof. It's a little high level, I won't get into it, but a neural network is able to approximate any function in the world. It doesn't matter what it is. And kind of the intuition of the proof is, imagine each of these different neurons, they only apply to one specific part of the function. So, because I only turn this on this neural network when I get input that's between 0.1, 0, and 0.1. And when I get that, all these are 0, this is 0.1, I come out, and that's the value I get. I get over here for everything in between there. And then if I go up higher, that turns off, and maybe this one turns on, and I can get values over here. And long story short, I'm able to approximate this function arbitrarily well. I mean, in order to do this, we do need lots of neurons, potentially an infinite amount of neurons to do it perfectly. And it's not a guarantee that we can find the right parameters to make this work, but the point is that it's possible. It's possible for this function and every other function. So all you have to do is you just have to decide your input. That can be whatever you want. And you decide your output. That can, again, be whatever you want. And then the neural network is able to learn or figure out what parameters are able to map the input to the output you want. So that can be, going back to our input examples, that could be image. I say, hey, what number is this image supposed to be? I say, hey, this is a 3. Okay, cool. And then neural network is able to predict this is a 3. So I give it just this big old fat ugly image, and it's able to understand this is a 3. Or or I can do something with time series, like what comes next time series. I can do something with text, just whatever you want, right? Okay, cool. So continuing, right, so the point is, we can do whatever we want, but the question is, how do we make this actually work? Like, how can we make it possible for it? How can you figure out these parameters? Because these things can get insanely complicated, and it's not like we can just like use our intuition and figure this by hand. Like, no way, it has to be done. The computer has to be able to figure this out by itself. So how does it do that? Well, in order to do that, we have to get into a little bit of calculus. Nothing too heavy, I promise. I could get really deep into this, but what we have to do is first we have to establish a loss, and we have to decide what we want to predict. So coming into here, it's actually easier if I just show this. So I'll restart this. We have this input. We say, for example, I want to figure out the classification for this specific dot right here, right? So I pass into the input, it makes a prediction, and maybe it says, hey, this is blue. Well, I say, well, no, it's not. It's supposed to be yellow, right? It's wrong. And then I do that for every single point in my data set. So over here, it's right, good, 0, 0 loss, 0 loss, 0 loss. Oh, okay, here we have some problems. Here we have some problems again, because you're supposed to be blue. And we just try to figure out, we make all these predictions about what the dots are supposed to be, and we figure out how wrong the neural network is. And then we calculate, or we give an estimate about how much loss or how much of a problem we have. All right, and then what we want to do is we want to find a way to make this loss go down. What we love is we love to be able to train a network and just have it get it right almost every single time. Like here we have almost 0 loss because it's able to predict it almost perfectly every single time. So how do we do that? Well, again, first we have this loss. And then once we have this loss, we want to minimize the loss. And how we do minimization in math, almost always, is with calculus. So imagine, for example, this is the output of the neural network. Or this is that loss landscape. We have maybe a bunch of parameters, and initially, when we make a guess, we guess over here. We have this much loss. And we say, okay, well, cool, but can we try to get that lower? Well, what we do is we take the derivative, and what the derivative does is it gives us a slope, or it gives us a direction about how we can minimize this loss. So again, like in this simple 2D example, this is a full neural network, but it's the same idea. It's a function, right? The function, we do an input here, we generate this value, and we say, okay, yeah, cool, but I want to go down. We calculate the derivative. Derivative tells us, okay, go this way. We go down that way, and by going step by step, we're able to approach the minimum or the 0 loss. And yeah, this is kind of a better example of that. So this technique, by the way, is called gradient descent. Again, we start with the potential to be the highest loss here. We calculate the derivative, or the gradient, if you will. we multiply the gradient by some learning factor just to make it a little bit smaller, and then we update our weights to accommodate that, okay? And step by step, we get the loss lower and lower and lower. Okay, so here, to make this more clear, I have a nice example right here. Okay, so this is a basic neural network. And what I want to do is I want to make it so that when I put in 1, I put in 1 here, I want to produce 0.5, okay? So the very first thing we do is we run these numbers and we see what the network produces. So again, following the same pattern we had before, we have 1 here, we have 1, the weights are 0.5 and 0.5 down here. So 1 times 0.5 plus 1 times 0.5 is 1, right? And the same thing down here. We then pass that through an activation function. In this case, we use something that's called the segue function. I mean, the details of why we do use that isn't really important, but the point is that we get this output. And so 1 becomes 0.731 and 0.371 over here. And now we need to calculate the final output. So what we do is we take this, we multiply it by 0.5 again, get this, multiply by 0.5 again, and we get this final value, again, 0.731, okay? All right, so, but this isn't what we want. We want 0.5. So we calculate the loss, and the loss is 0.231. We are this far from our target. So now that we have the target, what we're going to do is we're going to take the derivative of our bagel function and figure out how we need to update these weights, okay? All right, so the way that we take the derivative is we start at the right and then we work our way to the left. So starting at the right, we have this basic function. So this function, all it is y is equal to w1 multiplied by this. So yeah, sorry, it's a little sloppy here. Maybe I should just type it. That'll be better. Sorry. Yeah, there we go. Y is equal to w1 multiplied by 0.731 plus w2 multiplied by 0.731. Okay, that's all that this function is. We don't care about what came before. We only care about what comes here right now. Okay. And so what we do now is we take the derivative in respect to each of our different variables. So first we'll take the derivative in respect to w1. And if you don't know calculus, I mean, I don't know. I don't really have time to super explain the math, but when you take the derivative, what it becomes is y prime is 0.3. And once we have that, that's the gradient for the specific point, 0.31. And then derivative over here is kind of the same. So, okay, let's see. Sorry, let me clear this. Okay, oh, there you go, there's my mouse. Okay, all right, so, yeah, oh, okay, sorry. So, okay, so, sorry, my bad. I jumped ahead a little bit. I'm really sorry. So actually, what we do is we have this final value out here, 0.31, and we take the derivative in respect to our loss, or sorry, respect to this value. So sorry, okay, our loss is 0.231, and then the value over here, we take derivative with respect to that, and we end up with this value, okay? So this is 0.168861, and then from there, we continue to backpropagate further. So we take the derivative with respect to here, and the gradient will become over here to be, let's see. Oh yeah, so we have this loss, 0.23 multiplied by 0.5. We get this value over here, and that's the value down here also. And then if we take the derivative beyond that, we get the value over here, and that's 0.227. That's just taking the derivative with respect to sigmoid. And then we continue back on until we get to the final point. Anyways, so I'm sorry, I don't really mean to get too bogged down to the math because that's not really the point here. What I'm trying to do is I'm just trying to illustrate that we start from the right, we calculate our loss, we take derivative to the last value, and then we take that back derivative, we pass it back, and we continue all the way to the end, okay? And then once we have that, we have the derivative of the loss for every single parameter inside the neural network, okay? All right, so to make this a little more clear, I think what I want to do is I want to give you a coding example. So to do that, we will actually try to program this, and I'll show you how this is done, okay? So to begin, I'll create a new Python file, and what we're going to do is we call this AutoGrad. Okay. So, all right. All right, we're going to install Qlikla prerequisites library, and we're going to get started. Okay, so what I want to do is I create a value class, and then inside this class, so starting with the end in mind, what I want to be able to do is, all right, I want to be able to run the function, and we're going to create a really basic neural network. What it's going to be is it's going to be first A will be equal to 1, 2 or something like that. Then B will be equal to 3. This will be our input value. There we go. We have the input. We have a weight. And then we have a bias. Initially, we'll set this to 2 or something. It doesn't really matter. And then the output will be equal to the input multiplied by the weight plus the bias, okay? All right, and of course I can make this more complicated if I want to. I can add in another weight, for example, like maybe weight 2 will be equal to 3, bias 2 will be equal to 4 or something, and the output could be equal, then the output will be, let's see, this could be output 1 plus the bias. Okay, and I can go on and on, but the point is that this is the exact same structure. We just have these different neurons, if you will, and we add them and we multiply them together, and we want to be able to calculate the gradient of that. So to be able to do that in code, what I could do is I go into here. All right. And wherever we create a value, we first have to declare a definition for this object. We have the data, what the value actually is, and then we have children. And what this represents is if we have a graph, let's see. So neuron, 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 input, input. So for this specific neuron, it has a value inside of it, and it has these 2 children, okay? All right, so going back to my mouse. And then we also have an operation, which could be plus, minus, multiply, divide, just any basic mathematical operation. Okay, so, okay. All right, so let's go ahead and create these as public variables. Let's see, we also have a gradient, which will initially set to 0. And we have a backwards function, self_underscore backwards. And we'll just have that be an empty function where it really does nothing right now. And we have the previous elements will just be equal to the set of the children. Okay. And then we have the operation. Okay. Okay, so. All right, so now what if I want to add? How do I do that? Well, what we're going to declare is, so we want to add this value plus potentially something else, an other, if you will. And what this other will be is if this other is instance, other is value. So if it's already a value, then we do nothing. Else, we try to create a value out of it. Okay. Oh, sorry. Yeah. Other. Okay. And then the output of adding will be equal to value, where we have self.data, and we're adding the other.data. So we're just adding these 2 numbers together. And In this case, we do have two children. So when we add, the left child will be one data, and then the right child will be the other. So self, ourself, and then the other, okay? And the operation we're doing here is plus, okay? All right. And then we also declare the backwards derivative. So if we're doing backwards derivative, in the case of adding, all we have to do is we take grad, set that to out.grad, and other.grad, and we set that to out.grad. So again, it's just the sum of these, and we pass the gradient backwards. Okay, and okay, and we also declare our backwards function to be underscore this guy. Okay. Okay, cool. So let's try to make sure that we can understand this before we move on. Oh, and also got return out. Return out. Okay, there we go. Okay, so all right, so I have this input, and what I'm going to do is I'm going to turn it into a value object. Okay. And then I have let's see, then I have this bias. I'm going to turn it into a value. We aren't doing multiplication yet. All I'm going to do is I just want to add these two things together. That's it, okay? So let's do that. So added values will be equal to this plus that, okay? And we're going to try to figure out the backpropagation of this. Okay, so okay. Yeah, okay, that'll work. So let's go and give this a try. So initialize this. Okay, so I declare my variables for what this object is. I create the grade to be 0, previous backwards, and right now there isn't a backwards, there is no previous, no operation. Right now it's just a simple number. Okay. Then I come out of that. I do the same thing for this other variable. Then I go forward, and I'm adding these together. So what I did is I actually overrode the add function to go into here. So let's just step into there and see what happens. So both of these are already values. So the other will still be a value. Okay. And I update. So I add these two values together, add the data, add the value, and create a new value. And this time this value was created with an addition, and the children are the first input, and then the other child is bias, okay? All right, and now I declared this new value, which is just the addition of these two things. It's a mathematical operation on these two different values, okay? All right, and now let's suppose I want to figure out the gradient of this. So our function in this case is just y is equal to input plus bias, okay? So let's figure out the gradients. So for that, let's see, we calculate the grad. And let's see, am I doing this right? 1 second. Oh, yeah, so we have to actually add it. Sorry, my bad. Okay, we add the previous gradients to it, and that's all we do here. Let's see. Oh, okay, so sorry, I jumped ahead a little bit, my bad. So first we have to declare our backwards function. All right, so I want to do backpropagation on this very simple function. Y is equal to input plus bias. So to do backpropagation, what I have to do is I have to figure out the graph, if you will, where again, we just have these two simple nodes, node 1, node 2, and then we add these together and we create node 3. So first I need to figure out the topography of this. So I declare a variable called topo. All right, what I'm going to do is I'm going to visit all the children, and I'm going to create a tree. So def build topo. And here I just need to take some value. So if v is not in visited, I add v. And then for child in v underscore previous, I go backwards on them. Let's see, child, pull in there. And then once I got that, okay, so, all right, little topo, self, okay. All right, so what this is doing is I'm trying to create the tree. I'm trying to figure out, hey, so I'm the parent, I'm the top. What are my children? Well, to do that, I go into here. I, let's see. Let's see. 1 second. Oh yeah, so this is a set. What's inside my set right now? Oh, set. There we go. Okay, so this is a set of all the children that come before me. I'm visiting all the children inside my previous. Let's see, if they have any children, I have to add that to that. But once those children are built up, they can add it to it. So the kind of idea is, here if I draw it out, so I have this tree, potentially there's a lot of stuff that comes before this. So that connects to that connects to that. You know, the neuron connects from there to there to there. So what I do is I start over here at the top. I go through my children. So this child, and then I just call the same functions. That way they build their own trees. So this will by itself go ahead and build its own tree. And go back, build a tree, build a tree. There is no tree here. So once I get to here, this node will be more than this node. It'll do all the different children. So now that I have all the different children, well, all I have to do is I add this thing into my topography, okay? And yeah, so come back here. I build my topography, and now we need to begin doing gradient descent. So for my gradient, I first begin with 1. And then all I have to do is I go through everything inside of my tree. So for V, so starting from the right, in reversed.
Po ang imang telegram reverse.
Sorry? Sorry,
Can
was
you
there a
please
question?
mute yourself? Yeah, someone needs to be muted, I think.
Oh, sorry. Maybe I can do that. Okay, we're good. Anyways, okay, so let's see, where was I? Okay, so yeah, so that's how I do the gradient for that. Okay, so to make this more clear, I'm going to step through the code and just try to make sure we understand this all line by line. Okay. All right. So it's backward. Sorry, not backwards. There we go. Okay, so let's also add a quick little print statement. So I can pause here. Okay, here we go. So, all right, so I have these two objects. I have some inputs, and I have this bias. And here, 1 second. So to make it a little more clear about what's going on, I'm going to add a quick little function so that way we print out what's going on inside of here. So what this report does is it just makes it so that when I print, I get the data and the grad of this object. So, sorry, let me start over. So input, okay, there we go. It has a data of 2, right? And then it has a grad of 0. Okay, awesome. And bias over here. Bias over here, we have data 2 and a grad of 0. And then the added values right now, it's just these two add together, 2 and 2 and 4, okay? All right, and now I want to take the derivative. So how that works is I step into here. All right, I build a topo and I'm starting with myself. So going to here, visited right now is just empty because there isn't anything that comes before that. And 1 second. Okay. sorry, 1 second. If this is it, awesome. Oh, okay, there we go. So go to here. Okay, so there we go. So I'm starting with myself. So right now what I am is I am the added element. So V is just over here. I'm at the end of my graph. This plus this, that's the added value, okay? So I haven't visited V yet, so I go ahead and step in. Oh, I'm so sorry, I messed up. That's the bug, sorry. Let's see, there we go. Visited add V. Okay, there we go. Sorry, I had a small bug. Okay, sorry, let's start this over again. Okay, there we go. So right now, my visited is just the empty set. There's nothing inside of it. And I have this value, which is the output of these two sums together. And so because I haven't built this out, I step into it. I add this to my visited. I've now visited the end of my neural network, okay? Okay, stepping forward, I now visit my children. So in this case, my two children should be, of course, input here and then the bias, right? And then I go through each of these children one by one, and I build out what comes before them. So first I have, I'm pretty sure this is the input value. I build a topography for that. I go into that. All right. So right now I've only visited the output, but I have not visited this add. So I step into that. I add it to my visited. It has no children. And I add that to my topography. And anyway, so point is, once I get done with all of this, what I will have is this. So my topography is I have input 1, bias over here, and this added value. This is my entire neural network right now. It's pretty simple. There's not much to it. But yeah, and so I declare my grad to be 1. And then I go into everything aside here, and I calculate the derivative, okay? So first I reverse the list, so that way we're starting at the end. And then I calculate backwards. So to calculate backwards, I go into, let's see. Let me just make sure I'm doing this right. Okay, so V that backwards is, let's see, value underscore backwards. Let's see, this should be, sorry, 1 second. Oh, that's it. Oh, another typo. I'm sorry. That's supposed to be backwards. Backwards. Okay, there we go. Okay. Okay, there we go. So let's see. Let me make sure I'm doing this right. Backwards. Let's see. So the added values, I should have. Okay, yep, it's got the grad. Should have backwards. Oh, backwards. There we go. Sorry, I forgot this again. I'm so sorry. There we go. Okay, so should be updating that right this time. Okay, there we go. Okay, so in this case, all I'm doing is I'm just taking the grad, which should be 1. There we go. And then I take the other one and I add that to the grad over here, and that updates back there. There we go. Okay, so once all that's said and done, what will happen is Let's go ahead and get out of this. Okay, so I have the grad should have backpropagated into the inputs, and then the bias over here, and they did update. So initially these were 0, but now it's become 1. So the reason why it's 1 is, let's see, so, all right, so gradient for y is 1, and I take the derivative in respect to the input, and the derivative of that is 1, so that goes into the input. Then I do it over here, same thing over here, and the derivative gets passed into there. Okay. And right, so if I want to make this a little more complicated, I can do the same thing. I can add in a definition for multiplying. So let's just go ahead and do that really quick. So def underscore multiply. The derivative, I'm just going to copy and paste most of this because it's mostly the same. The only thing you have to change is that we are multiplying over here, and we also multiply by the other dots, other dot data, and actually, sorry, I meant out dot data. Wait, other dot data. There we go. And multiply by sub dots data. Let's see. Okay, there we go. Okay, so now that I have that in place, we can add the weight back in. So the weights will be, we'll initially set it to just some arbitrary number, like maybe this, and we can multiply these together, and this becomes our full network. Okay, cool. All right, so, okay, so now let's go ahead and try to train this. So what we do is, first of all, we have to declare an objective. So the objective will be, we want our network to produce the value of, we'll say 2, okay? So I have this input, or actually let's do something different. So the input will be 2. I want to transform the input of 2 to be 3, okay? So what I have to do is, we're going to create a quick little trial run. So def run trial, we have the inputs, we have the weights, and then we have bias. So let's go ahead and quickly convert these to value inputs. So weight will be equal to value weight. And then bias will be equal to value bias. And like before, we create the network from here. There we go. Okay, and we also want to declare our loss. So our loss will be equal to 2 minus, or sorry, our objective is 3. So we want it to be 3 minus the output of this. So network underscore outputs. There we go. All right, and we want the loss to try to get as close to 3 as we want. So here for draw a function, what we have is 0, 1, 2, 3. So if we guess 3, we want the loss to be 0. If we guess anything else, we want it to get worse and worse. So if we guess 2, then the loss will be 1. If we guess 4, then the loss will be 1 over here. And we can kind of go up from there. So what this function is let's see. All right, so we have it right over here. But we need to, but if we go below this, we need, so if it's a 4, so sorry, if, let's see. Oh, actually, it's more like, okay, there we go. That makes more sense. So if this value is 4, if it's over here, the 4 minus 3 is, of course, is 1, and we got this over here. But if the value is 2, then this will be actually -1, but we want it to be +1. So if loss.data is less than 0, all we have to do is we multiply by -1. Loss multiply by -1, and then we do backwards, and then we're done. Backwards, sorry. Okay, so let's go ahead and print a quick report of this. So we got the inputs, which will be inputs, create a new line, and we do something for the weights. And let's go ahead and do something for the bias. And network outputs. And loss. Okay, let's see. Did I spell that right? Oh, it's backward. That's confusing. Sorry. Okay, there we go. Okay. Okay, sweet. I think we're good to go. So let's go ahead and give this a try. So over here, we got this run. Using the same thing, we have the input of 2. We have the weight of 4, and we have the bias of 2. There's a print. Think. Okay, pause. Okay, let's go ahead and step through this bit by bit. Okay, so we have the input, we have the weight, we have the bias. We multiply these together, and we have this other network output, and which is 10, which is what I expect because C2 times 4 plus 2, that's 8 plus 2, that's 10, so everything looks good. All right, then we do the loss, and sorry, there's one minor upper function I need to quickly throw in. That would be, let's see, oh yeah, I need to turn this into value. And right now we only have add, so we have to quickly add a thing for subtracting, so we can do that. So to do that, that'll just be sub. And the only difference here is that we are subtracting. So let's see, just make sure I do this right. Let's see. Actually, an easy way to do this is, sorry, 1 second, is we can just reuse our adder function. There we go. So it's the same thing. We just quickly multiply by -1, and then we use our adder. Anyways, so we actually don't need this. There we go. That should work now. So step into this. Step into it. Go to here. Okay, there we go. Right. So in this case, we have a loss of 7. The reason why we have a loss of 7 is because the network outputted. Sorry. Network outputted 10, but we want 3. So 10. So we're off by 7. So what we can do is we can try to update the weights really quick. So we get out of here. All right. So what we did was, sorry, 1 second. Okay, here we go. So the input, we have to add a 4. The gradient is 4. The weight is, for the weight, we have to add 4, grad 2, value, we have grad 1. And then for the full output, we have 1. And then for the loss, we have 1. And so what we do is we subtract the gradients, and we try to update our weights that way. So we just do that manually. The only 2 weights we'll be updating are the weight and the bias. So we try this again. So for the weight, we have the gradient of 2. So let's subtract 2 to that. So 4 minus 2 is of course 2. And then for the bias, let's see. We have Oh, did I forget to? Oh, sorry, I did that job. Sorry, I didn't actually print that out well. There you go. So the bias, we have a gradient of 1. So we subtract 1 from this, and then we try again. Okay, and this time we made progress. So now our network predicts 5. We're getting a little bit closer. 5 is still 3 off. So, or sorry, 2 off from 3, our targets. So what we do is we just try to update again. And we just continue to do this iteratively. So for the weights, we need to go backwards by 2 again. So subtract 2 again. This will become 0. For the bias, we need to go backwards by 1. Okay, let's try this again, and we should get a little bit closer this time. Okay, and let's see. Network. Yep. Let's see. Number output. Okay. And so this time, what we have here is we overstepped. So kind of going back to the loss diagram, how it works is it's kind of a parabola where every single time we are over here, figure out what direction we need to go, we step down, we move forward and closer to our minimum. In this case, what we actually did was we stepped too far and we stepped way outside of here and we overshot. So we actually did following the gradient, did a little bit worse. And so maybe instead of taking a full step, going all the way down the gradient, we can multiply it by a small number. So again, let's go back to over here. Here we had the weight gradient of 1, 2, and the bias of 1. Maybe instead of going by, maybe we can multiply these by 1/2. So if we do that, this becomes 1, and then this becomes 0.5. And if we do that, this time that output is 2.5, and we're a lot closer this time. We're only 0.5 off. And so the point is, we can do this again and again, and this is how training works. All we do is we create the neural network by adding these, by creating this little simple formula. We calculate the gradient, we take the derivative in respect to every single value. And as we calculate the derivative to every single value, we know how far off we were off every single time. And that tells us how far we need to update the weights. As we update the weights, we get closer and closer to optimal, and the weights slowly learn or adapt to make it so that the input will match the output. And yeah, I think we're out of time, so I guess we'll stop there. So yeah, let's go back to the slides, and we have a few closing remarks. Let's clear all drawings. Let's go back to slideshow. And yeah, thank you so much. So I know it's kind of a lot, but are there any questions?
Yes, when will you be doing this? I'm very interested in this. I just had a real pressing matter tonight.
I'm really sorry. The audio is pretty bad. I didn't really understand that.
I was saying, when are you gonna do this again? Because I would really love to participate in neural networks, deep learning. So far, I'm using Google Colab to train and deploy my models, but understanding your practices would be awesome, man. I just want to see what your your area of expertise.
Awesome. Yeah. Yeah. So as far as like continuing teaching, that's Julia, can you answer like what the next lessons will be, or when we'll continue our lessons?
Yeah. So I think it was Pilon, right? Thank you for being with us tonight. So I am gonna show you the offer we prepared, and so Matthew is gonna be one of our instructors in our course, where he will basically take you step by step into this learning process. And if you missed the beginning of this presentation, we are going to be sending the email to all participants tomorrow. So you can kind of like go back in the part which you missed, because I know that you joined a little bit later. And so you can kind of like go over from the beginning of what Matthew was explaining. And then tonight you have a chance to become a part of this program and learn more from Matthew and other experts we're going to be bringing into this course. We created this system which will allow our students in 6 months to become professionals in this industry, become machine learning engineers. And so, I mean, it's a great opportunity. In the beginning, I mentioned a few facts about the industry that is blooming, is growing by 2030. Projections is going to be over $200 billion industry. In 2022, it was $19 billion industry. So the opportunity is great, and you got a chance to join our program tonight. Let me answer a few more questions, and then I'll just go over the special offer we prepared for you. I want to say thank you to everyone who stayed with us till the end, and thank you for great question, Kilon. And Tyman is asking, what programs should we use to learn the math you talked about at the beginning? If you could answer that one, Matthew.
What programs did I use to learn the math? Yeah, so I went to Brigham Young University. I studied applied computational math, and we learned all of this plus a lot more. So, I got just mostly for my bachelor's degree, and also I've been in industry for 5 years now. So, I've used all these tools, and just practice, I guess.
Yeah, and also what I wanted to mention is that don't feel overwhelmed. It is not going to be like straight to like deep, knowledge, like those examples that Matthew mentioned. It's a step-by-step learning program. And so we're going to take you from where you are, build the foundation of your knowledge, and then you will be ready, like go from one level to another level with your knowledge and in math as well. And let me share more slides. Matthew, if you could just help me to scroll through fast. And so who can become a machine learning engineer? I always say you got to have a desire to learn, and right mentor is very important. That's why we carefully choose who will be teaching you. All our instructors, they work in the industry and they would be able to mentor you. One more question from Kelon as well. Will we learn to use data science tools for data manipulation aside from machine learning?
Yeah, absolutely. So when it comes to machine learning, what I talked about more specifically was just actually making the neural network. But there's a lot more to it than that. A really big part of it is preparing your data sets. And I've, when it comes to that, there's lots of tools you can use. Postgres, S3, DynamoDB. There's lots and lots of tools to make it so you can collect really large data sets and help serve those for the machine learning models for your training. And as far as like data manipulation tools, there's also Tensor, PyTorch, and a lot higher level libraries than the ones I talked about. And so, absolutely.
Great question. Thank you so much, Kelon. On the next slide, I just wanted to show you the average salaries for machine learning engineers. So after 6-month program, you'll get a chance to be helped with your resume and internship. And on average, those who become machine learning engineers, they're making anywhere from $110,000 a year to $250,000. But in the beginning, 6-figure income, that's a great start. I wanted also to show you average salary from Indeed on the next slide. So it's about $161,000 a year, which is a great stream of income, considering flexibility and remote job where you can be working from pretty much anywhere in the world. It's a great advantage to have. A little bit about our sign it up, Killen. Let's get you started. So for everyone who stayed with us, I'm going to let you scan this QR code and join us with a special pricing. So Matthew, if you could help me to move with my slides. What will you learn? And Matthew already mentioned few techniques and models we'll be using, but also we do have a full curriculum, and I would be happy to send it to you with an email so you could know everything what you will be learning in this 6 months, because the program is going to be for 6 months. The classes are going to be 3 times a week. and it's 1 hour per class. If for some reason you missed the classes live, you can always watch the recording. My math is best, lots of syntax errors. It's okay. Everyone has to start somewhere, and if you have the desire to learn and right mentor, sky's the limit, I always say. On the next slide, I wanted to show you also what's included. We don't just give you the knowledge and the theory, but we also help you to apply those tools you learned. That's why we provide you with internship. We help you with your resume, mock interview. You can always retake and watch the recordings of the class, which is important too. So we basically, since 2016, we know what works with our students, what doesn't work, and we created the system which will help you in the 6 months. Do not just develop the skill set, but our goal is by the time you finish the program, you already have a strategy how to implement the knowledge you received during our program. And your success is our success. That's why we're even more interested in helping you to succeed than you are. On the next slide, I wanted just to show you our program. So we're starting on August 6th. We do have a limited amount of space for students, and our goal is to keep the group small, no more than 15, 20 people, because our goal is not just to make sure we have a lot of students, but our goal is to help each student to become successful. So it wouldn't be like a lecture in the university with 100 students where if you have a question, you have no assistance. Each student will be able to have mentorship and help with their learning process. On the next slide, I want to show you the classes. So it's Tuesday, Thursday, and Saturday, 1 hour. If you are on Eastern time zone and you can join 7 Pacific, it's about 10 p.m. Eastern. You can always watch the recording, and since the group is small, your questions will be answered, so you can reach out to one of our instructors. And also on the next slide, I would like to show you our training program. Those just the key points of what's going to be included. And as I mentioned, we'll be sending the curriculum to everyone who will leave you your information so we could help you to move forward with your enrollment. And the next slide, as I said, everyone who stays with us till the end will let you join us with a special offer. Usually this program ranges from $6,500 to over $15,000. And today and till Monday, you'll have opportunity to join at the price of $5,999. So I would encourage you, do not miss this opportunity. Tomorrow evening at 7 p.m. Pacific, I'm going to have another expert who will be sharing with us more. And so scan this QR code and sign up if you have any questions, if you need to arrange some payment plan, or if you're ready to join, let us know. So as I mentioned before, investment in yourself is the best thing you can do nowadays because the prices are only going up, inflation and everything. You got to be prepared to have an extra stream of income and flexibility in your career growth. And this is a great opportunity. The market is blooming. So now is the time to seize this opportunity and do not miss it. And once you get the skill set, you can be having a career which will help you to have stability in the time we're living in. And this is a great opportunity, and we help you to be prepared so you could be successful in this industry. And we have different instructors who are knowledgeable. And because the group is small, we take you step by step and help you to become an expert in this industry. Where 6 months down the road, you don't just have a great career, but you have a path for growth, and you also, have that flexibility which is necessary. And instead of spending 4 to 5 years, studying something what you wouldn't be even using, it's like I always give an example of doctor. You gotta spend at least 7 years in school, and then you invest at least 100K a year Here you got 6 month program, and by the time you already have a skill set, and the start salaries for this career over $100,000 a year, which is the great average income. So I want to welcome everyone to join Olivia Information, and thank you so much for being with us. If you have any more questions, let us know. Keelan is saying, my friend suggested based on shopping behavior algorithm and makes 160 a year in machine learning for Publix. Thank you for your example. But sky's the limit. You know, we have students who started with us a few years ago. Now they're making over $250,000. You know, and we do provide different range of courses, but this presentation was about machine learning engineering, and it's a great industry to be in. And it's never been a better time to get the skill set. And then earlier you get it, then faster you will be on the path to success. So I want to thank everyone again who stayed with us. And if you missed the beginning, we'll be sending the recording. And I want to invite each of you for tomorrow at 7 p.m. Pacific, same link. We're going to have another expert, and we'll continue because I want to give you an overview. I had different experts within this 3 days, and I want to give you an overview of this profession so you could make a quality decision about your future career. And I know that each day you learn something new, but I want to give you a bigger picture of the future you could create, because you have to have a lifestyle which you deserve. And the difference between successful people and not successful, and that successful people, they have more options, they have choices, and they can live the life of which they dreamed about. And so that's my encouragement to you. And I want to wish each of you to create the lifestyle which you deserve and be successful. And this is one of the vehicles to take you there. So I encourage you to not miss this opportunity. Thank you for everyone who's been with us. And I hope we'll see you tomorrow. Have a wonderful evening. And I want to thank Matthew again. You genius, and you blow my mind with all that numbers, how quickly and easily you made it look. You know, I felt overwhelmed at one point, but then I understand that, you know, you got to build foundation, and he didn't just start understanding it all, you know, overnight. So it took him time to learn. And that's why he can be your mentor, and he can take you where he already went. You know, he knows what works, what doesn't work, and he knows the latest tools which are being used in this industry, which is so important. You don't want to be learning something 2 years old, you know, because in this industry, like every month something new comes up, and that's why you want your mentor, you want your teacher to be there and to teach you the latest tools. So I hope you all do not miss this opportunity. If you have any questions, please scan this QR code and let us know how we can help you to achieve your career goals. And I would love to send you the recording. I don't see your name. It says iPhone. So please let me know your name, and we will be sending the recording. Sorry if you missed the beginning, but that's the reason we recorded everything. So I'll see you all tomorrow, and have a wonderful evening. Thank you again for being with us. And I wish you all to create your dream career and dream lifestyle. And I hope machine learning engineering would be that career path. Thank you again. And thank you, Matthew. And have a wonderful evening, everybody. Thanks. And we can stop recording.